Hey everyone, welcome back. Today we are covering data sources in Terraform, one of the most important concept you will use in the real project. Short video, pure theory, zero fluff. Let's go. So what is data sources? Simple. It lets Terraform read existing infrastructure without owning or managing it. So think of it like a resource block is you buying a house. Terraform owns it, manage it, can destroy it. So this is your resource block. If you ask for the data block is you looking up your neighbor address. You are just reading info, touching nothing. That's the entire mental model. Read only, no lifecycle, no destroy. So this is the Terraform data block. Next is syntax. So if you define the syntax, you have to write data keyword, then the resource type, and then your local name. And inside the curly braces, you have to write the filters, and according to your requirement, you can give the argument in the filter section. And how do you reference? You can reference it anywhere, like it required in case of EC2. Let's suppose you are fetching the VPC and you want to define the VPC inside the EC2 block. Then how you will use it? You have to give the data, then uh, dot, then AWS VPC, then another dot, then my VPC dot ID. So data is your keyword, this is your resource type, this is your local name, and this is your attribute. Okay, that's how you will fetch VPC in case of any resource, like you are creating EC2, RDS, or anything. Next is how it works. So first, Terraform evaluate your filter argument. Then it calls the provider's read API, not create, just read. The provider return the matching attribute. Those values become available across your entire config. And finally, zero infrastructure changes happen. So there are, first you have run the Terraform plan. So it evaluate your filter according to your argument. Then you have a provider API call, it API and read the data. And data return, basically the provider return matching attribute if available, then value usable across your config. No infra create modify ever. So there are two things to know about timing. By default, data source are read at plan time before anything is applied. But if a data source depend on a resource that doesn't exist yet, Terraform automatically defers it to apply time. That's been automatic since version 0.13. So that's the first thing. Next, advanced one. So every plan read all data source fresh in large configs with many data sources. This means more API calls and slower plans. Keeps that in mind. Okay, next is filter argument. Filters are how you tell Terraform exactly what to fetch. There are 4 ways to filter. Number 1, direct ID. You already know the exact resource ID, fastest and most precise. Second one, filter block. You search by tag, name or property, most common in real project. Third one is boolean flag. So you search by a most recent equal true, perfect for always getting the latest AMI. And the number 4 is tag based lookup. Basically you search by a tag name like prod VPC, dev VPC or etc. So I given the example as well. So here is warning, that is one critical. If your filter matches multiple resources but the data source expect one single result, Terraform throw an error. Always write precise filter. Okay, core use cases. When should you actually use data sources? So there are 5 scenario. First one is pre-existing infra. Someone else created a VPC or security group. You don't own it, but you need to reference it data source. Like we have some members in the team and someone else created the VPC, like networking team, and I want to use it. So I will use the data block and fetch the VPC ID and use into my Terraform. Second one is dynamic value, like AIM-ID, availability zones, certificate ARN. These change over time. Never hard coded them. Let a data source the current value every time. Third one is cross stack sharing. You have split your infra into multiple Terraform configs. One stack need output from another. That Terraform remote state, which is coming into the next slide. Fourth one is secrets. No hard coding. So you should never hard code password or API keys. Pull them from AWS Secret Manager, Vault, Password Secret Manager, and the Vault or SSM parameter store. These are the AWS service using a data source at plant time. Last, that is fifth one, local file and templates. Read a startup script or a JSON config from your file system and inject it directly into a resources. Next is Terraform remote state. This is a special built-in data source. No provider needed. So it read the state file of another Terraform config and give you access to its output. So there is a classic real world pattern. You have a network state that create VPC and subnet. Your app stack read those VPC ID using remote state. Your DB stack reads subnet ID from that app stack. Each layer consume output from the layer below. Clean, separate, no duplication. Supported backend included S3, GCS, Terraform, Cloud, Azure Blob, all the majors one. So next one is depends on with data sources. Terraform built its dependency graph automatically. Most of the time it just works. But sometimes our data source need to read something that a resource in the same config will create. Terraform can't always detect that on its own. So without depend on, and there is a with depend on. So let's see what is without depend on. So Terraform read the data sources too early before the resource exists. Result error or stale data. With depend on, you explicitly tell Terraform to wait until the resource is created first, then read the data source safely. With depends on, you explicitly tell Terraform to wait until the resource is created first, then read the data source safely. So there is an advanced note. Overusing depend on force data source to apply time resolution, which slow down plans. Advanced note. Overusing depends on forces data sources to apply time resolution, which slow down plans. Use it only when Terraform automatically detection fails. Next is resource versus data source. So quick comparison to cement this. So I've created 3 columns: aspect, resource, and data. So aspect is basically our block keyword, create infra, destroy infra, in state file, drift detection, reference syntax. So let's start from the resource block itself. So it's create infra, destroy infra, full lifecycle, in state file, also drift the detection, reference with type, like type, then dot, then name. Then we have a data block. So create nothing, destroy nothing, only a cache, result in state, reread on every plan, reference with data, dot type, dot name. The keyword and reference syntax are the two things to burn into memory. Next is state, scope, and provider. So let's start from the state. So state are data source are not lifecycle managed. Terraform only cache the last result. If you run Terraform destroy, the external resource is not deleted. Terraform just forget the cache, and if that external resource gets deleted outside the Terraform, the next plan will fail. Next one is scope. In the root module, a data source is available everywhere inside a module if it's local to that module. To share it across module boundary, pass it as an output. Next one is provider. Every data source belongs to a provider, and that provider must be configured first. The only exception are built-in data source like Terraform remote state. Those need no provider at all. Last one, mental model and summary. So 2 quick decision. Question before you reach for a data block. Does Terraform own this thing? If it resource, so yes. If it's no, then it's mean it's a data block. Is the value dynamic or coming from outside the config? Yes for the data, no, use variable or local. And the one liner to remember. Data source, let Terraform ask question about the world. Resource are Terraform's answer. That's it for the data source. If this helped, drop a like and subscribe for the rest of the Terraform series. See you in the demo video. Thank you.